Welcome once more, Cougar Academy Algebra 2B to 6.6, how do you create polynomials with certain zeros? So now we're going backwards and we are actually going to create the graphs of polynomials so that they give us certain things. So I drew this little polynomial here. The idea is just to remember that what we do is we call these things zeros where it crosses the axis. There's a zero, there's one, and there's one. A little bit of our graphing review. So the idea of this lesson is to create a polynomial that goes through certain zeros. Okay, so it's almost like we have targets in mind. We want to hit those targets. Okay, so directions, right? A cubic polynomial function with integral coefficients that has the given zeros. Sounds a lot of confusion, right? Or sounds confusing perhaps, but really it's not bad. Okay. So cubic polynomial function with these zeros. So I'm going to give you these here. Now what these are is the points above, perhaps, now not exactly. Let's say, so this would be our -3, okay? This perhaps is our -1/3, and then perhaps this is our 5. So we're just going backwards to create this graph. What we do is we write these as factors. So here's the little trick. So to go from 0 to a factor, we're just going to make it opposite. So x plus 3. Okay, so make factors that are opposite. Okay, x plus 1/3. And then lastly, x minus 5. So we go from zeros to factors. Okay. The end of the game is we're going to have f of x equal those. Now, once you recognize that, zeros to factors, switching the signs, okay, really, you have your option, and it's just going to be multiplication from here. Now, yes, we have a fraction, so that'll be a little tedious with us. But what I would recommend is just remember your multiplication skills, and we'll start by foiling these last two here. So x times x is x squared, x times -5, -5x, 1/3 times x plus 1/3 x, and minus 5/3. Combine your like terms like the olden days, x squared. Feel free to use your calculator. I would continue to write it as a fraction, -5 plus 1/3. As a fraction is -14/3, okay, x minus 5/3. And then don't forget about this x plus 3 out front, okay, and then it's just a triple multiplication. So we still have f of x out front, and you can use any letter for your function, and it's just going to be multiplication again. So x to the third minus 14/3 x squared minus 5/3 x, and then 3x squared minus, so 3 times 14/3. Let's see if that, it's just silly me. It's going to be minus 14, of course, because 3 and 3 cancel. And then minus 5. Because 3 and 3 would cancel again. Okay, from here, just add again. And again, if you didn't catch that, you can use your calculator. So times -5/3 is just -5. Adding everything together, x to the third, -14/3 plus 3 is -5/3. -5/3 minus 14, -15, -47/3, and then minus 5. So that is our function that goes through all those zeros. So again, just create opposite factors, okay, multiply, 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 and that's really about it. If you wanted, you could graph this, and you should see that when you do so, it'll go through those original points, those original zeros. -3, -1/3, and 5. Okay. Next up, so again, number 2 here, so just another example. Switch it out as factors, x plus 5/3, x minus 3, and x minus 5. Do the old switcheroo. You could pick any two to FOIL first. I like to stick with the last two. So x squared minus 5x minus 3x plus 15, which is x squared minus 8x plus 15. We're going to distribute the x plus 5/3. So x to the third minus 8x squared plus 15x plus 5/3 x minus 40/3 x, and then 15 times 5, 25x, or just 25, sorry. And again, that's just all of your distributing. So I went through it pretty quickly, but hopefully you can stick along here. X to the third, -8 plus 5/3 is going to be -19/3. Oop, and that should be a squared. Okay. Minus, so let's take 15 minus 40/3. It's actually plus 1 2/3, 5/3 x, and plus 25. Okay, we'll call it g of x. It doesn't really matter, but that's that one there. Okay, the last two examples, similar idea. These are just little curveballs. So when we write opposite factors, this is x plus 1, x minus 1/2, and really the last one here, x minus 0, you could just write it as x, and that actually makes the problem pretty easy for us here. So x plus 0, x minus 0 is the same thing. Let's call it q of x. And I'm going to actually multiply these first two here because the last one's going to be real easy. X times x, x squared, minus 1/2 x, plus x minus 1/2. Don't forget the x from before. X squared plus 1/2 x minus 1/2. And then we have that x, and we'll just distribute that to everything, making it x to the third plus 1/2 x squared minus 1/2 x, and that is the function. So it can be easy when you have just a factor, or a 0 of 0 is pretty nice for you there. Okay, let me make sure. Yeah, I think everything's good from there. Okay, the last type, so some more terminology to look at. When we see 2/3 multiplicity of 2. That is one pair. That just means we have it twice. So 2/3 twice. If it said multiplicity of 3, that would be 3 times 4. You'll just see it 2 times. So when we write this as a 0, we can just think of it as x minus 2/3, x minus 2/3, writing it out twice. And then we have the x minus 0 again, or just x. And I'll write it in dots here. And really, that's just going to be, we'll say h of x, writing it out twice and then foiling. So x squared minus 2/3 x minus 2/3 x plus 4/9. Okay. 2/3 times 2/3. And then times that x. And we'll add our like terms. -2/3 minus 2/3 is -4/3. Again, if you are like, I don't know what's going on, just use your calculator for fractions there, and it really will be fine. So x squared minus 4/3 x plus 4/9, and distribute that x, and that just makes it x to the third minus 4/3 x squared plus 4/9 x, and that's it there. Okay, so little curveballs. That is the last lesson actually in chapter 6 here. So kind of tying it all together, just remember opposite factors. 0 is x minus 0, or just x, and multiplicity means write it out twice. Okay, and then it's just your multiplication skills. So nice job. Keep up the practice, submit all that stuff, and great work, guys.